Welcome to lesson 6.3, where we are going to talk about U substitution and the reverse chain rule. Now, here's what I want to talk about first. Let's go up to the top of our notes. Now, we remember when we do chain rule, we have that mama and baby thing that we talked about clear back in chapter 2 or 3. And when we talked about that, we talked about taking the derivative by layers. So for this particular problem, let's start with number 2. I would take the derivative of the outside layer, leaving the inside alone, and then I have to multiply by the derivative of this inside layer right there. So I would multiply by the derivative of 1 plus 5x, which would be 5. So we have the derivative of the outside times this hook-on factor, or this derivative of the inside. Now, when we're doing the antiderivative, we would do the opposite. So if you look at number 4, that is the same thing we got there. We just moved the 5 in front. And we know that the antiderivative is just going backwards. So the antiderivative of this would be sine of 1 plus 5x. Because if the derivative is this, then the antiderivative would be what we started with. Now notice this hook-on factor of this 5 right here, when we take the derivative, this hook-on factor, the 5, appears. So when we take the antiderivative, this hook-on factor, this 5, disappears. Which makes sense. If I take the derivative and it appears, then the antiderivative would make it disappear. So that's kind of the gist of what we're talking about in today's lesson. We're taking the antiderivative and we have to find that hook-on factor so that it disappears. Now, let's try this in our first example. Let's do number 6 first. So I look at number 6. I have two things happening here. Do you notice that one of these things is the derivative of the other? So whichever one is our original, we're going to call it u. So we're going to say u equals 2t cubed plus t squared. Now we're going to take the derivative of this u. So, sorry, let me label this really quickly. Call that u. So du dt, which is a way we've written derivatives in the past, would then be 3t squared plus 2t. Something we've done quite a bit. Now I'm going to do one other step that might be a little weird at first. I'm actually going to multiply both sides by dt to take it out of the denominator and bring it to the other side. To get this. So I know that du equals 3t squared plus 2t dt. Now let's go back to our integral. I'm going to rewrite things a little bit. I'm going to put my u, the t cubed plus t squared, I'm going to put that first. And then my 3t squared plus 2t, I'm going to put that second. Which I can do because this is multiplying, and 3 times 4 is the same thing as 4 times 3. Anytime we're multiplying, we can move things around and we're fine. Now the reason I did this is because now we can see right there, there's my u. Well, right here, all of this, right here, look. So 3t squared plus 2t dt, 3t squared plus 2t dt. All of that is du. It's equal to du. They're the same thing. So I can substitute du for this whole thing right there. So now I can rewrite my integral as u du. U du. Now the reason this du is important, that d letter, so whether it's dt or du or dx, whatever it is, that tells you what variable you're integrating in. One way you could think of it is it kind of tells you what language you're speaking. So this du, let's say that's English. So this du says that this whole integral needs to be in English, aka this whole integral needs to be in u's. If we have any other letter, we can't do it. So just like this example right here, dt, let's say that's Spanish. That dt means this whole integral needs to be in Spanish, aka that whole integral needs to be in t's, no other letter. And then same thing with over here, dx. That dx tells us the whole integral needs to be in x's, or French, whatever you want to say. That d letter is just there to tell you what variable you should be in. It has no part in the actual integration process. No part at all. It is just there to tell you what language you should be speaking. What variable should be in your integral, and no more. So I've now got this u du. We're all in the same language. We're all in u's, so we're good. And this u has a secret 1 there. So at this point, this is a power rule. So if I go up here, right there, there's my power rule. X to the n dx. That's exactly like what I've got here. U to the 1 du. So this is going to turn into, reminder of our power rule, u to the 1 plus 1 over 1 plus 1 plus c, our constant of integration. So u squared over 2 plus c. And my last step is to resubstitute what u is back into my equation. So I go back up here to the top, there's my u, t cubed plus t squared. So I'm going to substitute that in. And there we go. There's our answer. So that is our first example of u substitution. In the next video, we'll do some more examples.